Hello guys, Winston here. Anyone who's been in the aerospace world probably knows a coworker or two with a wooden aircraft display on their desk or bookshelf. These models are cool and all, but where's the love for things without wings? Since I have a 5-axis CNC, I thought it would be cool to make myself a wooden model of a rocket. But unfortunately, because a rocket isn't a good fit for the work envelope of the Pocket NC, I had to settle for something a little stubbier. I picked a Dragon capsule, partly because I'm a SpaceX fan, but also because the CST-100 and Orion look super generic. It's like they stole the blueprints of the Apollo capsule and just scaled it up. Sure, it's a tried and true aerodynamic profile, but man do they look boring. Because I'm time constrained and my CAD foo isn't as strong as it should be, I opted to start from a model on Thingiverse. Importing an STL model like this into Fusion, there is some mesh reduction that needs to be done, and though I hate culling details, 10,000 polygons is still plenty to define all the major features of the Dragon. Docking interface, hatches, parachute compartments, maneuvering thrusters, heat shield geometry. Because of how I was planning on work holding the capsule though, there was going to be a hole in the heat shield side of it. To cover it up though, I thought a bottle opener would be a perfect addition to the model. Not only would it allow the model to have a practical function to justify its desktop real estate, but it would also allow the model to sit flat on a table. However, I needed a specific type of bottle opener to make this work, and Rockler carries exactly what I was looking for. They have these inset bottle openers that are 2 inches in diameter that can be integrated easily into a number of projects. I told Rockler I wanted to make a bottle opener, and they were kind enough to send me some. So then I took my STL model, scaled it so it had a diameter larger than 2.5 inches but less than 3 inches, then I got it as concentric as I could relative to the B-table model. There are actually 2 versions of this setup, one with the Dragon upside down and one right side up. The inverted version was setup number 1, where I would carve out the heat shield and also add in locating features for the bottle opener and work holding fixture. Since I didn't want to have to modify my Dragon STL, the toolpaths for these features would be developed on a surrogate model with their own setup. To keep track of the vertical alignment of all these features and how I would flip this piece, I sketched things out on my notebook. Then I started chipping away at the model with 3D toolpaths. For setup 1, I faced my stock block down to where the model began, then I adaptive cleared around the bottom, and finally I used a radial toolpath to smooth out the heat shield. I limited it to only the area that wouldn't be covered up by the bottle opener. Then the toolpaths from the surrogate model came into play. On the flip side, I'd basically adaptive out everything, use a couple smaller end mills to refine details in the docking interface area, and parallel finish everything else. Alright, let's get to the garage. My stock material of choice for this project was maple. It's a nice dense wood with grain patterns that look fine on their own. I bought some 3-inch square by 12-inch long turning blanks off eBay to use here, which I cut down to 3-inch lengths. I made a little MDF platform that I could screw the blocks into, which would then bolt into my B-table. Then I loaded up an 1/8-inch long reach end mill in a standard length tool holder and ran my first operations. Those first few cuts looked and sounded a lot deeper than what I was expecting, and I quickly deduced that my stock block was offset from my B-table more than I had anticipated. You see, the ER40 collet and retaining nut protrude from the machine about 1/16 of an inch, so you can't actually set something flush against the B-table. At this point, I already thought I'd ruined the first prototype by facing the block too short, so I switched to my backup stock. I went back to Fusion and adjusted the position of my model to compensate for the offset and tried again. This time, it worked. After the initial clearing, I ran the second toolpath from my surrogate model to add my bottle opener and fixturing cavities. Once that was done, I unmounted my part to do the reverse side operations, but first I had to reposition my work holding fixture. Because this fixture would be a reference surface for me, I needed to ensure it was located exactly at the origin or B-table offset, so I moved my end mill 2 inches away and used a 1-2-3 block to dial in its position. This probably isn't the best way to do things, but right now I'm in woodworker mode, not machinist mode. I loaded up my 1/4-inch end mill and started to adaptive clear all the remaining stock. But I wasn't thrilled with how my cuts sounded. I was getting a lot of chatter and spindle loading, so I had to back down on my feed rates. Yeah, I know people say you should speed things up to change the harmonics of the cut and reduce chatter, but that's not happening on the Pocket NC. A 60 inch per minute speed limit means the only direction you can adjust is down. These toolpaths would need some fine-tuning in the future. I got through these operations and switched to my 1/8-inch shank end mills to detail the docking interface. Then it was time for the home stretch, smoothing everything out with a 1/4-inch ball end mill. And I'm kinda mad at myself here, but I programmed this toolpath with the wrong end mill. I told Fusion I was going to use an 1/8-inch ball end mill, not a 1/4-inch one. The idea was that it could get finer details, but in my head I wanted the higher surface speed of a larger end mill to perhaps get cleaner cuts. That disconnect and thought process created a toolpath that caused my pocket NC to drive my end mill too deep radially into my part. So I fixed the toolpath and finished up this defective Dragon to validate the new G-code. By this point, I figured out that test article number 1, which I'd previously faced a little too aggressively, would actually have enough margin left in it to successfully cut out a Dragon capsule, so I threw that back on the CNC to try again. But disaster struck late in the game. At the last step, I forgot to measure my tool length offset. The ball end mill was plunging just slightly too deep axially. In multi-tool operations, it's common for a shop to have a tool holder dedicated to each end mill. That way, changing an end mill is quicker and you don't need to probe your offsets every single time if you have a tool table. I'll show that off if I get a couple more tool holders in the shop, but for now I'm doing everything manually, and in this case my mental checklist failed me. Even though this Dragon wasn't perfect, it ended up with a much smaller blemish because I caught the problem early. I installed my inset bottle opener and wiped on a thin coat of mineral oil. The spalting really makes this one look special in my opinion. Now, I could walk away from this rather tedious project having completed this somewhat academic CNC exercise. I successfully brought in an STL model, figured out how to fixture and locate it, and developed the right toolpaths to cut it out. But I've now invested a couple evenings into this project and I don't have a single perfect part to show for it. So, of course I had to try again. And by this point, I'd gotten some feedback from Xander, who I frequently reference in my 5-axis videos, that my toolpaths could be improved a little. The problem with my adaptive toolpaths originally was that the containment boundary I'd sketched up was too restrictive. The end mill was spiraling into the stock and cutting from the inside out. Adaptive toolpaths work best going from the outside in, so I widened my boundary beyond the stock extent so Fusion would know there was room to plunge outside the stock and come in purely from the side. This toolpath is a lot cleaner than what the original was, and I enabled both ways adaptive clearing to speed things up. If the rapids on the machine were faster, I probably wouldn't bother, but with a speed limit of 60 inches per minute, I figured that I might as well maximize the amount of time I had the cutter engaged. I also finessed the cutting parameters a little to go easier on the spindle and the work holding. Remember, there's only a single bolt holding this wooden part in place. I ended up going with a 0.2 inch depth of cut with a 0.05 inch optimal load. Another change I made was to kludge together programs 1 and 2 so I didn't have to manually load a second program halfway through the machining of the heat shield side. And finally, because of an instance where some chips got jammed in the rails of my Pocket NC and prevented the machine from homing, I MacGyvered some way covers for the CNC. With those improvements made, it was time to cue the music and make a montage. Finally, some drama-free machining. With a validated process established, I knocked out a couple more Dragons in case anyone wanted to buy one, but honestly, selling isn't really the priority here, and if these don't move, I'll probably just give them away as gifts. I price these Dragon bottle openers more like art pieces than engineered products because of the massive time investment. Beyond the evenings I spent in the garage, I also spent a bunch of hours wrestling with the STL file and developing my toolpaths. These costs simply cannot be recouped through Etsy unless I can somehow machine these in less time to bring the price point down to a place where I can sell them in volume. And for that to happen, the Pocket NC would need to be at least 3 times faster than this. The discussion about my troubled relationship with selling for profit and running a business is a pretty long one, which is why I left it for this week's episode of the Digital Fabrication Experiment, my podcast with fellow hobby machinist Eddie Kramer. You should really check it out if you haven't already, hint hint. And while I'm shamelessly plugging things, I also want to shout out everyone on Patreon because your support helps justify impractical experiments like this one. Cheers. And that's all I have for this project video. I do plan on machining a Dragon 2 model around the same time the thing becomes operational in early 2019, but I actually want to model that myself in Fusion. It's hard to refine your toolpaths when you're working with an STL, and I want something in a native CAD format so I can manipulate it, pick contours, and machine it more surgically. I want to thank you all very much for watching, and I'll be back with another CNC related project video in a week or two.